Solve the equation d2x dt squared minus 3 dx dt plus 2x equals to 2 exponent 3t, given that at t equals to 0, x equals to 5, dx dt equals to 7. So we get the Laplace transform of this equation. Laplace transform of d2x dt squared. This equals to a squared x bar minus s x naught minus x1. Laplace transform of dt dx dt, this equals to s x bar minus x naught. Laplace transform of x bar, then Laplace transform of exponent 3t, this equals to 1 over s minus 3. Now when we substitute in the equation, now this is this, which is a squared x bar minus s x naught minus x1. Now we multiply it to the Laplace of this is this. We multiply through by -3, so we have minus 3 s x bar. Now this becomes positive because of this sign, so it will be plus 3x naught, then of course plus 2x bar equals to now 2 over s minus 3. Now at this point we now insert in the initial conditions. They are saying that at t equals to 0, x naught equals to 5, x1 equals to 7. So the equation now becomes a squared x bar minus, now x naught is 5, so this would be 5s, be 5s, then x1 is 7, so it will be minus 7, then minus 3s x bar plus x naught is 5, x naught is 5, so here we have 15. We take this 5 times 3, then plus 2x bar equals to 2 all over s minus 3. Those that have x bar, we put them together, so here we have a squared minus 3s plus 2, then we take out x bar, this, and that. Then we have minus 5s, negative 15 plus negative 7 plus 15, we have plus 8. This is negative 5, so equals to 2 over s minus 3. So here we have s squared minus 3s plus 2 x bar equals to 2 over s minus 3. This crosses equal sign, it becomes plus 5s minus 8. Now we can factorize this. There are two numbers. When you add, you get negative 3. When you multiply, you get 2. So the numbers will be negative 2 and negative 1. So this becomes s squared minus 2s minus s plus 2. We factorize this. So common here, it will be s into s minus 2 minus 1 into s minus 2. So you have s minus 1, s minus 2, x bar. We have simply factorized that, so we have x bar equals to 2 over s minus 3 plus 5s minus 8. Now because we want to calculate x bar, we divide both sides by this expression, so that, say therefore x bar will be equal to, now we have 2 over s minus 3, then s minus 1, s minus 2, plus 5s minus 8 over s minus 1, s minus 2. So x bar equals to, what will be the LCM? We want to add this and that, so the LCM will be s minus 3, s minus 2, s minus 1, s minus 3, s minus 2, s minus 1. So here we shall have 2 plus 5 minus s, 5s minus 8 into, now it would be s minus 3, s minus 3. We open up the bracket, we shall have 2 plus 5s times s, we have 5s squared, 5s times 3, we have minus 15s, minus 8 times s, minus 8s, plus 24 over s minus 3, s minus 2, s minus 1. Like terms here, we have 24 and 2, that is 26. So we have 5s squared, negative 15 plus negative 8, we get negative 23s plus 26 over s minus 3, s minus 2, s minus 1. So x bar equals to this. So we shall get the partial fraction for this expression. So we shall say that 5s squared minus 23s plus 26 over s minus 3, s minus 2, s minus 1 equals to every linear factor in the denominator gives rise to a single partial fraction. So this will be equal to a over s minus 3 plus b over s minus 2 plus c over s minus 1. Then we multiply both sides by the original denominator, so on this side we remain with 5s squared minus 23s plus 26 equals to a. So here when you multiply this with the a, s minus 3 will cancel with the s minus 3, so we remain with a into s minus 2, s minus 1 plus b. S minus 2 will cancel with s minus 2, so we remain with s minus 3, s minus 1, then plus c into s minus 1 will cancel with s minus 1, so we remain with s minus 3, s minus 2. This equals to, we now open up the bracket, so we have a into s times s, we have s squared, s times negative 1 minus s, 2 times s, we have minus 2s, negative 2 times negative 1, we have plus 2, then plus b into s times s, we have s squared, s times negative 1, we have negative s, negative 3 times s, we have negative 3s, negative 3 times 1, we have plus 3, plus c into s times s, we have s squared, s times negative 2 minus 2s, negative 3 times s, we have negative 3s, negative 3 times negative 2, we have plus 6. So we are saying that 5s squared minus 23s plus 26 equals to, now we open the bracket, a squared minus, now minus s minus 2s, we have minus 3as plus 2a, then plus now minus s minus 3s, so here we have plus ba squared minus 4bs, then plus 3b, then here we have plus cs squared, then minus 2s minus 3s minus 5cs plus 6c. So we collect those that have s squared, so we have a plus b plus c, this one, a squared, we take it out. Then those that have s, we have minus 3a is this one, minus 4b minus 5c, then s, then constant terms we have plus 2a plus 3b plus 6c. So we equate the corresponding coefficients of s. So we start with s squared. We have a plus b plus c equals to 5. Coefficients of s, we have minus 3a, minus 4b, minus 5c equals to, on this side, minus 23. Then constant terms, we have 2a plus 3b plus 6c equals to 26. So we can solve the two equations. So I can make A the subject in the first equation. A equals to 5 minus B minus C. So where there is A in the second and third equation, I replace with this. So in the second equation, minus 3 into 5 minus B minus C minus 4b minus 5c equals negative 23. So here negative 15 plus 3b plus 3c minus 4b minus 5c equals to negative 23. So here we have 3b, negative 4b, will remain with negative b, negative 5c plus 3c will remain with negative 2c, then negative 15 crosses to the other side, it becomes positive, so this equals to, this will be 8, negative 8, negative 8. Call it equation X. Then we also substitute in the third equation where there is A. So we have 2, this A, into now 5 minus B minus C plus 3B plus 6. 6c equals 26. So we have, so when you open up this, you have 10 minus 2b minus 2c minus 2b minus 2c plus 3b plus 6c plus 3b plus 6c equals to 26. So minus 2b and 3b will remain with the b, minus 2c plus 6c will remain plus 4c equals to 10 crosses to the other side becomes negative 26 minus 10 will remain with 16. Call it equation Y. So we have our equation X, which is minus B minus 2c equals to minus 8. So we can solve the two equations. I can make B the subject in this equation, in that B equals to 16 minus 4c. So where there is B in the second equation, I replace with this. So I have minus into 16 minus 4c minus 2c equals to minus 8. Open the bracket, minus 16 plus 4c minus 2c equals to negative 8. this and this, we have 2c, 4c minus 2c, we have 2c equals to 16 crosses with the side, the other side becomes positive. So 16 minus 8, we have 8. C equals to 8 over 2, which equals to 4. So if C is 4, we can get the value of B. B will be equal to 16 minus 4 times 4 to be 0. We can get the value of A from this equation. A equals to 5 minus B minus C. 5 minus B minus C, which equals to 5 minus B is 0, minus C is 4. So A equals to 1. Therefore, the partial fraction, which is this one, so therefore, the partial fraction will be equal to, now this will be our x bar will be equal to, now A is 1, so it will be 1 over s minus 3, so plus B is 0 over s minus 2, then plus C is 4 over s minus 1. So x bar equals to this. X bar equals to now 1 over s minus 3. This is 0 plus 4 over s minus 1. Now to get the value of x, we get the inverse Laplace transform of this equation. The inverse of x bar, the Laplace inverse of x bar equals to the inverse of 1 over s minus 3 plus 4 over s minus 1. So the Laplace inverse of x bar will be x equals to the Laplace inverse of this will be exponent 3t, and then plus the inverse Laplace transform of 4 over s minus 1, it will be 4 exponent t, and that is the solution of the given equation. X equals to exponent 3t plus 4 exponent t. Thank you for watching and listening.